Let's see how the strategy for finding the tangent line to a curve at a point works out in this particular case where we have a curve defined parametrically. So the formula is defined through x equal 3t and y equal ln t plus 3. And let's say that we want to find the tangent line at the point where x is equal to 1. You can see from the graph that there is such a point. However, notice that first of all, this curve is given through a parametric formula, which means that we still have to figure out the other coordinate of this point. So let's do that. Let's find the other coordinate of the point. Well, we're told that x is equal to 1. If we look at the first equation of the parametric curve, it tells us that the x is equal to 3t, and that implies that t has got to be equal to 1/3. Now we can use this value of t in the second equation to find out what is the y coordinate. This turns out to be ln of 1/3 plus 3, and if you put that in the calculator, it turns out to be approximately 1.9, and that's exactly where you see the point on the curve in the graph. Oh, by the way, you may want to check how the ln of 1/3 plus 3 has become 3 minus ln 3. It's a little bit of an algebraic review of ln properties, so I'll leave that to you. Alright, so we got the formula, we got the point, now we need to find out the slope. Well, for a parametric curve, the slope is given by the ratio of the derivatives of y and x with respect to t. And in this case, the derivative of y with respect to t is 1 over t. The derivative of x with respect to t is just 3. So we end up with 1 over t divided by 3. But remember, the value of t that we are interested in is 1/3. And so if we put that 1/3 into our formula, we end up with a 3 in the numerator, a 3 in the denominator. And that tells us that the slope is actually 1. So the last thing that we need to do is put all of this into the point slope formula, which I remind you, it looks like this. Y equals m times x minus x0 plus y0, where of course x0 and y0 are the coordinates at the given point. So let's see. We'll start from m. Well, we've figured out that m was equal to 1, so we're going to put a 1 in there. Then we're going to look at x0. We found out that x0, actually that was a given, that was equal to 1. That was the x coordinate we wanted. And so that means that our first bracket becomes x minus 1. And then y0, if we have computed that to be 3 minus ln 3, so we're going to add that at the end. And that's it. That's the equation of the tangent line. Now what you may want to do is, just for your own sake, is put that equation in your calculator and make sure that this line does indeed look tangent to the curve that we have seen at the beginning. So I'll leave that also to you to check as a final check.